We all want a world powered by clean energy, right? But there's this massive, kind of invisible challenge that could stop the whole thing in its tracks. Today, we're going to dig into the incredible technology being built to solve it.
I mean, it's the dream, isn't it? A world that runs on clean, renewable energy. But to make that dream a reality, we have to solve this one enormous puzzle.
It's not just about building more turbines or putting up more solar panels. The real challenge, the one that keeps grid operators up at night is, well, it's a lot more complicated than that.
Right, because with renewables, you're not just managing energy, you're managing the weather. And as you're about to see, getting that balance wrong has some huge consequences.
Okay, so the heart of the problem is really the nature of renewable energy itself. It's incredibly powerful, for sure, but it's also incredibly fickle.
So, take a look at this. This is a power curve for a wind turbine. If the wind is blowing too slow, you get zero energy. Nothing. Then, power ramps up super fast. But, and here's the kicker, if the wind gets too strong, the turbine has to shut down completely for safety. And your power output? It drops right back to zero. Imagine trying to manage a national grid with that kind of stop-and-go power source. It's a nightmare.
And the stakes are just incredibly high. I mean, think about it. If you forecast way too much wind power and it never shows up, you could be looking at blackouts. But if you forecast too little, you might have to fire up these really expensive, really dirty backup power plants, we're talking fossil fuels, just to fill the gap. Or you might just have to waste perfectly good, clean energy. It is a constant, high-stakes balancing act.
So the big question is, how do we get better at predicting the weather? We've been trying for decades, honestly, but recently, a whole new generation of artificial intelligence is completely changing the game.
You know, forecasting has come such a long way. We started with these pretty basic statistical models back in the 70s, then came these complex physical simulations in the 90s, which was a huge step up. But now we're in the era of deep learning and these enormous foundation models, AI trained on just massive data sets. This isn't just a small improvement, it is a fundamental shift in what's even possible.
So what's the secret sauce here? What makes these new AI models so much better? Well, it's all about moving away from trying to find a single right answer and instead learning to embrace uncertainty.
Okay, so the old way of doing things was called a point forecast. Basically, it gives you one number. That's it. It's what you see in a typical weather app. The weather tomorrow will be 22 degrees. It's simple, sure, but it doesn't tell you how confident the model is. Is it definitely 22 degrees, or is that just its best guess? But modern AI uses something called a probabilistic forecast. Instead of one number, it gives you a whole range of possible outcomes and the probability for each one. For a grid operator, this is an absolute game changer, because it tells them not just what's likely to happen, but also what's possible. And this slide shows what makes a good probabilistic forecast. It really needs two things. First, it's got to be sharp. That means a nice, tight, useful range. Second, it has to be calibrated. That just means its probabilities are accurate. So if it says there's a 95% chance of something happening, it actually happens 95% of the time.
So to create these super sharp, perfectly calibrated forecasts, the AI needs to be fed a massive and really diverse diet of high-quality data. It really is all about the right ingredients.
And there are two really crucial types of data. First, you've got your numerical weather predictions, or NWPs. These are powerful simulations of what the weather might do, but they can have biases. The second type is historical measured weather, so what actually happened. That's the ground truth.
So here's the crucial part. When you feed the AI both types of data, something pretty amazing happens. As these researchers from the Arctic University of Norway found, the model learns to use that real-world historical data to spot and correct the errors in the future-looking simulations. It's basically learning from the simulation's past mistakes to make better predictions. How cool is that? And we are talking about an incredible amount of data. Decades of history, real-time updates, and hyperlocal data from, get this, over 250,000 personal weather stations. It's all aggregated by services like the Weather Company and fed into the AI to give it the most complete picture of the atmosphere possible.
So, what happens when you put it all together? Well, when you combine this really powerful AI with this incredibly rich data, the results are, well, they're nothing short of stunning.
And this just illustrates the difference perfectly. On the left, you see a forecast using only the weather simulation. See how wide and uncertain that is? It's not very helpful. But on the right, when you add in that historical ground truth data, wow, the forecast becomes incredibly sharp and so much more accurate. You can see how the prediction interval just hugs that red line of actual observations much, much more closely.
But we can do even better. The final step is to layer in real-world domain knowledge. For instance, the AI might predict a massive surge in power, but we know this wind farm has a max output of 54 megawatts. So when we tell the AI that physical limit, the forecast gets even sharper and more realistic, as you can see right here. It's the perfect fusion of data-driven AI and real-world physics.
The scale of this operation is just staggering. I mean, platforms like the weather companies are handling over 200 billion data requests every single day, all to power these kinds of forecasts for industries all around the world, from aviation to energy.
So why does all this matter? Well, because every single percentage point of accuracy we gain in these forecasts makes our grid more stable, it reduces wasted energy, and it brings us one step closer to a world that can confidently run on clean, renewable power.
You know, we started by just trying to predict the weather, to manage our energy. But this technology, this ability to create these sharp, calibrated forecasts from massive, complex datasets, is really a tool for taming uncertainty itself. And it leaves you wondering, what will we point it at next?